Okay, last part C here starts with continuing the metric prefixes. Like I said, a metric prefix gives a value of the unit in relation to the base unit. So like centimeter, the base unit would be meter, and centi means 1/100th of the base unit, which is 1/100th of a meter for centimeter. Same is true for some of the lesser known prefixes, like the fancy U with a tail on front, also known as micro. Converting 3.5 grams to micrograms, first we need to know what is the relationship between micrograms to grams. And if we look at the metric prefixes, we see here that micro is this fellow right here, 1/1,000,000th or 10 to the minus 6 of the base unit. Okay, so that means, in other words, when it says 10 to the minus 6 over here, what it means is 1 microgram is 10 to the minus 6th of a gram. So we're going to use that conversion factor in going from grams to micrograms. We start out with 3.5 grams, which as usual, we can think of that as being the numerator of a fraction where it's divided by 1, times a conversion factor, and we hope to get an answer that's in micrograms, and we can consider that to be a fraction divided by 1 also. So what we're going to need in conversion factor is to get rid of grams. Grams are on the top to begin with, so we want grams in the denominator in the conversion factor, and we want to end up with micrograms for the answer, so we want that on top in the conversion factor. And our relationship tells us that we have 1 microgram for every 10 to the minus 6 grams. And so it's a little hard to see because things got written on top of each other, but it's 1 microgram over 10 to the minus 6 grams. So that's what that is. And so if we take 3.5, okay, 3.5, whoops, and we can ignore the ones again. 3.5 divided by 10 raised, okay, raise it to a power of minus 6, we get that. 350,000,000. 3.5 million, 3,500,000 is what we get. Now that number there is very long, but actually without a decimal point, that only has 2 significant figures, which actually is what we want here. 3.5 is 2 significant figures, but the 1 microgram and 10 to the minus 6 grams, that is a conversion factor within the metric system. That's considered an infinite number of significant figures. And so our answer should have 2 significant figures. Like I said, 3.5 million is 2 significant figures if there's no decimal point. But with numbers that big, it would be better to put the number in scientific notation. I wouldn't mark you wrong if you don't, but that would be a preferable answer here. You can go from here to here just by locating the hypothetical decimal point. I'm putting that decimal point in parentheses just to remind us that we shouldn't actually write the decimal point in if we're going to use this form of the number as our answer. But that's where it is if we want to move it to get scientific notation. And to get scientific notation, we need first part of the number to be between 1 and 10. And so we need to move the decimal point to the left. 1, 2, 3, 4, 5, 6 places. Where we end up with 3.5, that's between 1 and 10. And we move the decimal point 1, 2, 3, 4, 5, 6 places in the direction that makes the number smaller. So the exponent has to be positive to compensate for that. So 3.5 times 10 to the 6th micrograms. All right. There are also cases where you will have to convert from one metric unit to another metric unit when both of them have prefixes. In both of these previous examples, one of the measurements had a prefix and the other one was a base unit. So we went from milliliters with a prefix to liters, the base unit here, and we went from grams, the base unit, to micrograms with a prefix here. So a lot of times, they'll both have prefixes. And what I would recommend in this case would be to do the conversion in more than one step and stop off at the base unit along the way. Okay, so an example of that might be say converting 1.56 deciliters to milliliters. You could do that in one step if you know the relationship between deciliter and milliliter. And as you get a little more experience with the metric system, you might be, you might be tempted to, actually try it. I wouldn't recommend it even if you think you know what you're doing, because it's too easy to mix things up or too easy to like move the decimal point the wrong way in your head and screw things up. If you do it the way I suggested, doing it in more than one step and stop off at the base unit along the way, then it's pretty hard to mess things up. All you have to do is know the values for the prefix deci and milli in this case. Okay, so the way you'd probably want to go on this conversion would be go from deciliters to liters to milliliters. And this is what I mean by stopping off at the base unit. Go from one unit with a prefix to the base unit to the other unit with the prefix. Okay, so to go from deciliters to liters, we need the relationship between deciliters or deci and the base unit. So we come to the prefixes here. We see deci, d1/10 or 10 to the minus 1 or 0.1 is another way of putting it. But I'll leave it in exponential notation like the chart does. Okay, so that we have this, so we can go from deciliters to liters now. And we need the relationship between milliliters and liters. So when we come over here, we see that we have milli is 1/1000th or 10 to the minus 3 of a unit. So 1 milliliter is 10 to the minus 3 liters. Okay, and then we just have to keep in mind what unit goes where in order to make things cancel out the way we want. when we're setting up the conversion factors in this case. So if we start with 1.56 deciliters, we can consider that to be a fraction, as a number divided by 1. And to go to liters, we've got the relation, we want deciliters in the denominator of the conversion factor so that they'll cancel. And we want liters to be in the numerator of the conversion factor. And we have right here that 10 to the minus 1 liters is equivalent to 1 deciliter. Okay, so we note that deciliters do cancel, and we end up with liters as the unit for the answer. And 1.56 times 10 to the minus 1 is 0.156. Okay, we don't have to worry about significant figures yet because this is only the first step out of 2. The second step, we can take 0.156 liters and convert that, which we can think of as being over 1, and convert that to milliliters, which we want finally. Okay, this time we want liters in the denominator of the conversion factor, and we want milliliters in the top so that it will come out as the answer. Okay, we already saw up here there's 1 milliliter for every 10 to the minus 3 liters. And so we notice that liters definitely do cancel, and we end up with milliliters as the unit. And 0.156 divided by 10 raised to the negative 3 power is equal to 156 milliliters. Okay, looking also at significant figures, we've got 3 significant figures in the answer. Going back to the very beginning of the problem, we have 3 significant figures in the 1.56, the 10 to the minus 1, and the 1. That is a conversion factor within the metric system, so that's considered infinite. The 0.156 was also 3 significant figures, although you really shouldn't count the significant figures here because that's just the same as it was up here. And if you didn't round off, you might end up with too many in the answer of the first step. So this is 3 significant figures there. 1 milliliter for every 10 to the minus 3 liters is, again, infinite because it's a prefix within the metric system. Infinite significant figures, as I was saying a moment ago. And so therefore, the smallest number you notice is 3, so that's what we should have in the answer, and that's what we've got. So we're okay. So this is just an example of how you can go from one unit with a prefix to another unit with a prefix. Okay. So just one more example of that kind of thing. Metric, the metric system involves a lot of units besides the ones that, that you're probably familiar with. Liters and meters and things like, and kilograms or grams rather, and things like that. But as long as they're metric units, you can use metric prefixes with them. So for instance, the unit of watt, which is what the capital W means, that's a unit of electrical power. That is a metric unit. It has a, defined in terms of metric, other metric units. And therefore you can use metric prefixes with it. And the relationship is the same as it is with any other metric units. The nice thing about that is that you can do a lot of unit conversions in the metric system without even knowing what the base unit is. I mean, you didn't in order to do this, you don't even have to know what capital W means. All you have to know is that you're starting out with milli of something and you want to go to giga of something. And that's all you need to know. Just look up the values for the prefixes on the table and go to work. So we're going to go from milliwatts to the base unit, which would be watts in this case, to gigawatts. Okay, so we want to know the relationship between milli and the base unit. So in this case, it's milliwatts. Milli stands for 1/1000th, or 10 to the minus 3 of a unit. So that means 1 milliwatt is 10 to the minus 3 watts. We also want to know the relationship between watts and gigawatts. Giga is way up here near the top, and it says a billion, or 10 to the 9th of a unit. So 1 gigawatt is equal to 10 to the 9th watts. Okay, so we're dealing with some pretty big numbers in part of this anyways, but basically we treat them the same as we do with any other conversion. To start with 3.65 milliwatts, we will have a conversion factor that we multiply that by, and we will get a certain number of watts. If we're going from milliwatts to watts, that means we want milliwatts to cancel. So milliwatts will go in the denominator of the conversion factor, and watts will go in the numerator. And our relationship is 1 milliwatt for every 10 to the minus 3 watts. All right, so you can ignore the ones. Notice that milliwatts cancel with milliwatts, and we end up with watts as the only unit that doesn't cancel, and that's what we want. 3.65 times 10 to the minus 3. Well, that's scientific notation. So you could just write it like that. 3.65 times 10 to the minus 3 is the answer. Or you could write it as 0.00365 watts, because that's what it is as the decimal form. Okay, so I'm going to start the second step with the decimal form of the number, just because it's a little bit easier to enter into the calculator. And we've got watts as the what we're starting with in the second step. We need a conversion factor so that we can end up with gigawatts. If we want watts to cancel, then watts will have to go in the denominator of the conversion factor, and gigawatts will have to go in the denominator of the conversion factor. So notice that watts cancel. Oh, sorry, we didn't put the numbers in yet. Be sure to put the numbers in. 1 gigawatt is 10 to the 9th watts. Okay, so watts cancel, gigawatts is left as the answer, and we have 0.00365. 0.00365. Okay, divided by, because it's on the bottom, divided by 10 raised to the 9th power. And that equals 3.65 times 10 to the minus 12. Okay, this is one case where it would not be reasonable to write that as a decimal number, because you'd have basically 11 zeros before the 3, and I don't want to sit there counting them. So a number of that magnitude should definitely be in scientific notation. 3.65 times 10 to the minus 12. When dealing with unfamiliar units, it's especially helpful to remember what I said back at the beginning of the first part of this lecture, where I said that if the unit gets bigger, the number should get smaller and vice versa. In this case, you're starting with milli-unit, which is a small unit, 1/1000th of a unit, and you're ending up with a giga unit. And again, it doesn't even matter if you know what watts are. But giga is really big. It's a billion of something. So you're going from 1/1000th to a billion, and that means the unit's getting bigger. It's getting a lot bigger. And so the number should get smaller, a lot smaller. And it went from 3.65 to 3.65 times 10 to the minus 12. That is my idea of getting smaller, definitely. 3 significant figures, infinite significant figures, again, 3 significant figures, infinite. So 3 significant figures it is, and that's actually what we ended up with in the answer. So that worked out nicely. There are also metric conversions using special units. By that, what I mean is, like I said before, units like the milliliter or the liter, especially, since they have equivalents in other more official metric units, at least in the SI system, you might have to do conversions involving those. So for example, if you had to convert or let's put it like this, 3.65 cubic meters to milliliters. In this case, we're starting with cubic meters, and we want to end up with milliliters. We know that length units to the third power would be units of volume. And of course, anything related to liters is also a unit of volume. And now we just have to remember how to convert one to the other. So remember I said that 1 milliliter is equal to 1 cubic centimeter, and 1 liter is equal to 1 cubic decimeter. Out of these two, I think the first one would probably be the easier one to use here. And what that means is you have to get from cubic meters to cubic centimeters. This also gives us the chance to see basically how to convert units that are raised to a power also. So if we have cubic meters, if we can get to cubic centimeters, then we can get to milliliters. So this is our little plan here. We have 3.65 cubic meters, which we can think of as being over 1 for simplicity's sake. And now we need to convert that to cubic centimeters. That's our first step. Off the top of my head, I don't know how many cubic centimeters there are in a cubic meter. Actually, I do, but let's pretend I don't. And what we can do instead, though, is how many centimeters are there in a meter? That I know, or that I can look up, and we can then worry about what to do about the fact that it's raised to the third power. So between meters and centimeters, we know that any kind of centi unit is 1/100th of a unit. All right, so 1 centimeter is 10 to the minus 2 meters. And so if we want to end up with centimeters to the third power, we should at least have centimeters on top of the conversion factor. And if we want to get rid of meters to the third power, then we're probably going to need meters in the denominator. And the relationship between centimeters and meters is 1 centimeter for every 10 to the minus 2 meters. But now what about the fact that these are actually cubic meters and these are regular linear meters. They won't cancel out, or actually they'll cancel out, but only partially. One of these 3 meter dimensions will cancel out with that one, but then you still have the other 2. And actually, we want cubic centimeters instead of centimeters anyway. So the easy thing to do would be just take that entire conversion factor and raise it to the 3rd power. Remember that the 3 applies not only to the numbers within the parentheses, but also to the units within the parentheses. So this is now 1 times 1 times 1, or 1 cubic centimeter for every 10 to the minus 2 times 10 to the minus 2 times 10 to the minus 2 cubic meters is essentially what that means. And so that means that we can now cancel cubic meters with cubic meters. Don't cancel the 3 because it still applies to everything else in the parentheses. And that also means that we're going to get out cubic centimeters as the answer, the unit for the answer. Okay, so let's try this now on a calculator. 3.65. Okay, 3.65 divided by, now I would put parentheses around the 10 to the minus 2. 10 raised to the negative 2 power, parentheses, and raise that to the 3rd power. And we'll see what we get. That makes sense because it's a big number. Okay, 365,0000, or in other words, 3.65 times 10 to the 1, 2, 3, 4, 5, 6. Okay, 3.65 times 10 to the 6th cubic centimeters. And so that's how you can get that. It's cubic centimeters because, of course, that's cubed also. Whatever you do, don't forget to cube the 10 to the minus 2, or the numbers inside the parentheses also. Sometimes when I'm doing problems like this, I will actually circle the exponent, or the power of the fraction, just to make sure that I don't forget what I'm doing and sort of go right by it. So in other words, 3.65 times 10 to the 6th cubic centimeters. And we actually now know that cubic centimeters is the same thing as milliliters. So you're effectively done. You could just say that this is equal to the same number, 3.65 times 10 to the 6th milliliters. Or if you want to make it really officially official, you could take 3.65 times 10 to the 6th cubic centimeters and multiply it by the relationship between cubic centimeters and milliliters, which is 1 to 1. There's 1 milliliter for every 1 cubic centimeter. Cubic centimeters will cancel. You get milliliters as the unit for the answer, and the number stays the same because it's 1 over 1. So 3.65 times 10 to the 6th milliliters. Okay, so that is, I think that's probably pretty much the end of part 3 of this lecture. So we'll have to continue on. We'll do a few more examples of unit conversions in the next lecture, and then we could talk about the scientific method for a little bit, and then finally we'll be done with chapter 1. Okay, so I'll see you, I guess this week it'll be Wednesday. I'll see you Wednesday.